If you think of a bird running toward a box of games, you might imagine a playful Kia parrot from New Zealand, not a wild falcon, but striated caracaras do just that. My name is Katie Harrington, and I work in the Comparative Cognition Unit at the Messerly Research Institute. Through the Johnny Rig Project, I've been studying striated caracaras for several years now in their natural habitat in the Falkland Islands. These curious falcons live isolated on the remote Falkland Islands, surrounded by ocean and high winds, and the unpredictability of where to find their next meal. Having a flexible mindset might help them solve these challenges. Striated caracaras explore everything. They constantly probe new things they encounter, and they tend to identify new food sources in the process. We wanted to empirically test how flexibly striated caracaras can innovate solutions to novel challenges. Innovation can be broadly thought of as the ability to invent behaviors, or to apply what you know to a new context. It plays a fundamental role in species ecology and evolution, and can be a useful measure for cross-group comparisons, as well as a proxy for general intelligence. A lot of what we know about innovation and avian cognition in general comes from corvids and parrots. Striated caracaras from the closely related falcon family provide an opportunity to look beyond these two groups at a new avian model that could help us understand cognition in the wild. To test striated caracaras' innovative abilities, we adapted a paradigm that was used to test problem-solving abilities in tool-using cockatoos. In this paradigm, individuals are concurrently presented with 20 different tasks to solve for a food reward. Participants can shift among the tasks to solve as many as possible during a single trial. This allows researchers to calculate rates of innovation and subsequent performance, and to assess group and individual level approaches to problem solving. For our study, we took a subset of these tasks and created a portable puzzle box that we could then present to wild striated caracaras. We chose tasks that could be feasibly solved with the foot or the beak, such as tipping a seesaw forward to reveal the food reward, removing a twig so a platform falls and the reward drops, breaking through a paper window to retrieve the reward, or pulling a wire to release a drop-down window to access a reward. Then we flew the box to the Falkland Islands to begin the first cognitive studies with this species in the wild. We tested all birds individually once per day. Birds were allowed at most 5 trials during our study period, so that other individuals could have an opportunity to participate during the limited winter daylight. Caracaras were interested almost immediately, like this 8-month-old male who's approaching the box for the first time. He solved all 8 tasks during his first try and went on to be our fastest problem solver. And our most eager participant, running to start his 5th trial 5 days later. The caracaras performed remarkably well. They rapidly approached the maximum number of solutions and solved the puzzles faster with each trial. In total, 15 caracaras solved the puzzles, using different approaches and flexibly moving among the tasks. They performed on par with tool-using Goffin's cockatoos, and even outperformed the cockatoos on some tasks, perhaps due to ecological differences. Striated caracaras' remarkable flexibility in approaching the tasks, coupled with their eagerness to participate, and unwariness of humans, highlight these birds as a promising new model for studies of avian cognition. Striated caracaras' curiosity might help them survive, but it doesn't come without risks. With less than 2,500 striated caracaras in the world, their small population on the Falklands is inherently vulnerable to changes in their environment. Studying how they learn can tell us something about how flexible and how adaptive they might be in the face of new challenges. More broadly, studying these birds may also tell us something about how different cognitive abilities evolved in nature.